This video is about how to rationalize a two-term real denominator using what's called a conjugate. Simply multiply by what's called the conjugate. It ends up being almost the same thing as the denominator, except you change the sign between the two terms. So in this case it was negative, we make it positive. If it was positive, you make it negative. You just switch it. But then of course, whatever you multiply by the bottom, you have to also multiply by the top, because really we're just multiplying by a convenient form of 1 here. Now, across the top, 1 times the numerator is just, of course, the numerator, root square root of 3 plus 1. Across the bottom, I'll do this the long way and then show you how there's a little bit of a shortcut here. We're going to have to multiply this binomial times this binomial, which we could use the FOIL method. First times first would be square root of 3 times square root of 3, or square root of 3 squared. Outer times outer would be plus square root of 3. Inner times inner would be minus square root of 3. And last times last would be minus 1. Now notice, if we simplify a little bit, these terms match, but they're opposite signs, so they'll end up canceling out. And across the top, in the numerator I have the same as we saw before, square root of 3 plus 1. Down below, the square root of 3 squared turns into 9, and I have a minus 1 there. So final step would be to simplify that denominator and make it 9 minus 1, which is 8. And so now I've written the expression that I started with, but with no root in the denominator. I want to zero in a little bit more on what happened here with this conjugate. Recall that if I had an expression of the form a minus b times a plus b, this is really a difference of two squares, and the unfactored form of it would be a squared minus b squared. So instead of foiling this out every time, we could use this shortcut and just recognize what a is and square it, recognize what b is and square it, and probably skip right over to this step instead of having to do this every time. So that's just a little shortcut that I'll demonstrate on the next example. For this next example, let's try the same idea. We're going to multiply by the conjugate of this denominator, since that's what we want to rationalize. The conjugate, of course, is the same thing, but change the sign. And you have to multiply the numerator by the exact same expression, so those should match. This time, the numerator originally was more than 1. So this time 2, we have to distribute to each term above, giving us 2 times the square root of 2 plus 2 times 1, which is 2. Now down below, I'm going to use the shortcut I mentioned previously, where we take the first term, in this case square root of 2, and square it, and then we subtract the last term, which in this case is 1, and square it. This is using the difference of two squares formula, which says that a minus b times a plus b is equal to a squared minus b squared. Now let's take this a step further, making it 2 square root of 2 plus 2 all over. The square root of 2 squared would be 4, and 1 squared is 1. And so the last step would be to write this as 2 square root of 2 plus 2 all over 3. Look at our next example. This time it's a bit more complicated, where the numerator has a radical part to it, which is fine. All we really care about right now is rationalizing the denominator. So I'm going to multiply by the conjugate of the denominator, which is square root of 3 plus 1. Notice that all that changes is the sign. And I'm going to multiply by that exact same conjugate above. Please take note that these signs must match. Now let's continue. The multiplication across the top will be a bit more complicated this time. We'll have to FOIL this, or multiply binomial times binomial. Square root of 3 times square root of 3 would be 3. Outer times outer would be plus square root of 3. Inner times inner would be also plus square root of 3. And last times last would be plus 1. Across the bottom, we'll use our trick where we take the a, or first term of the denominator, and square it, minus b, or the second term, and square it. If we simplify the numerator, the 3 plus the 1 will turn into 4, and then we have plus 2 square root of 3 all over. The square root of 3 squared would be 3, minus 1 squared is 1, for a final result of 4 plus 2 square root of 3 over 2. Now, sometimes at this phase there's even more simplifying to do. Do you notice that there's a common factor between all of these integer parts? If we factor a 2 out of the numerator, ending up with 2 plus the square root of 3, now these 2's can cancel, and so our final simplified answer would be 2 plus the square root of 3. In this next example, I'm going to use the same method of multiplying by the conjugate of the denominator, since that's what I want to rationalize. Of course, I have to multiply by the exact same thing above. And I'm going to use some parentheses here to stay organized because we have to do some foiling across the top especially. So first times first would be square root of 15. Outer times outer will be plus, well, square root of 5 times square root of 5 would be just 5. Inner times inner would be plus 3, which is square root of 3 times square root of 3. And last times last would be plus square root of 15, which would be square root of 5 times square root of 3. That's all over the denominator, which we now know we can use the shortcut of first term squared minus second term squared. And so let's boil this down a little bit more. Above, we have 5 plus 3, which is 8, plus 2 times the square root of 15. All over down below, the square root of 3 squared would be 3, minus the square root of 5 squared would be 5. So let's continue here. This is now 8 plus 2 square root of 15 all over negative 2. But notice once again, all of these numbers that are not in roots have a common factor, and we can factor that out, namely 2. If I factor a 2 out of the numerator, I get 4 plus square root of 15 over negative 2. Now be really careful with this negative sign. Technically, a negative sign in either a denominator or numerator means the whole fraction is negative. So these 2's cancel, but the negative sign does not cancel. That remains out in front of this expression that's left, which is 4 plus square root of 15. And so if we distribute the negative, we can end up with negative 4 minus the square root of 15 as our final simplified result. In this last example, we're going to use the same idea. Note this time the denominator has a plus in between the two terms. So this conjugate will be a square root of a minus the square root of b. Remember, you just change the sign. And I have to multiply the numerator by the exact same thing, so a square root of a minus square root of b above also. And now we have the fun of multiplying straight across. On top we have square root of a times square root of a, which would be a. Outer times outer would be minus square root of a times square root of b. Inner times inner would be minus square root of a times square root of b. And last times last would be plus b, which would be square root of b times square root of b. That is now all over the first term, which is a squared, square root of a squared, minus the second term, which is the square root of b squared. Notice that this negative sign in between these two terms, using the shortcut, has nothing to do with this sign right here. It's using the general formula, which requires it to be a negative. If you have a plus b times a minus b, it's the same as a squared minus b squared. So this negative sign is really what matches this one here. Now let's proceed to simplify the numerator. We can combine these two like terms, making them minus 2 square root of a square root of b. Down below, the square root of a squared would be a. The square root of b squared would be b. We could leave it as is, or you could combine these roots to be a plus b minus 2 square root of ab all over a minus b. This isn't a whole lot simpler, but there's nothing else we can do, so we'll leave it at that.